Welcome back to my channel. If you're new here, hi, I'm Miss Flores. If you're not new here, hello and welcome back. Today we are going to be talking about light energy. In our last units, we were talking about energy and its transformations, electrical circuits, and now we're really only focusing on light. So why are we focusing on light? If you look outside, we notice that light is everywhere. Light takes up so much space. However, it's not really in the way that you think it is. Light actually travels in a straight line. Now, I know what you're thinking. Well, if I turn on the lights in a room, all of it turns on. Every filled space is there. Well, not always. If you look under a desk, you have shadows. If you are walking outside, you see your own shadow. Underneath every object, it's going to be blocked off. Well, actually not always. Depending on what the item is. Sometimes not all the light is going to transfer through. So it's really important to think about how light behaves. Let's look at some definitions to get a better understanding of what it all means. So literally, what even is light energy and how does it work? So it literally is a natural occurring energy that happens whenever you have your electric or magnetic fields popping off, pop out sis, and it's giving off that natural, glow, radiation, whatever, and it is being absorbed by objects. Now, here's the thing when it comes to light energy. Light isn't always absorbed. You have three different main actions that happen whenever it comes to light energy. So how does light even actually behave? And what does it mean by behaving? Behaving really means its reaction. So if light is hitting an object, how is it reacting with it? Now, there are three main behaviors that we have. We have reflection, refraction, and absorption. Another way to describe it is transmitting. Transmitting really means if it's going through it or not. That's another little category that we're going to focus on later. But for the main part right now, those are the three behaviors. Reflection is a bouncing back of light. If you look at yourself in water or in a mirror, you see your reflection. If I have refraction, refraction means the light is bending. If you think about water and you have a glass and you put a straw in it, you get to see that sometimes the straw looks a little crooked or broken. That's literally refraction. The light is coming in from the air into the water, which is your mediums, your states of matter, but it's looking like it's changing. It's not actually. Yes, the light is changing its direction, it's breaking, it's bending, but the straw's still the same. It didn't break. The water didn't change. It's just how the light is behaving. Then you have absorption. Absorption is a taking in of light. For example, here in the carpet, I don't see anything else. The light is going to the floor. Nothing is passing through the floor, so it's blocking it out. I also see light can be absorbed through different things. If you go outside for a while and you sit in the sun, the heat is absorbing. The light is absorbing. That's why you have heat. Let's go ahead and talk about some of our vocab words. First, we have reflection. Reflection is a bouncing back of light. If I look at myself in the mirror, I'm going to see my reflection at the same angle that I am viewing it at. If I have a mirror in front of me and I decide to go a little bit elsewhere, I'm looking at an angle and it's going to reflect back in the opposite direction. That's why it's super important to remember. It's bouncing back the light. Next, I have refraction. Refraction is the bending of light. One way to think about it is a very popular glass prism. I know that if light is hitting it at one angle, it's going to scatter the rest of those particles out in order to see the other colors. That's what we call the electromagnetic spectrum. It's all of the rainbow colors that we get from pure white light. Now, next I have absorption. Absorption is a taking in of light. All of these light particles, the light rays, are going into an object and they're not bouncing back, they're not bending, they're just being taken in. So let's do some motions in order to remember. First we have reflection. Reflection. If I'm looking at my reflection in the mirror, think of the Mulan movie whenever she was very sad. She's like, when will my reflection show? You have the mirror and you're looking at yourself. Water is another great example of understanding reflection, especially because once it is flat, you see the light bouncing back. Refraction. Refraction. The light is bending. Refraction. So if you know that if light is hitting an object, it's going to bend the light, and it's going to look either larger, smaller, crooked, or broken. Then you have absorption. Absorption is the taking in of light. So light is coming in and it's staying there. When we think of absorption, sometimes we can even think of standing outside. We know that if we're outside in the sun, we get to see all of the light rays hitting us, and we feel it until it transfers to heat. Next, I'm going to go ahead and talk about transparency. So what even is that? Transparency is trying to identify how much light is passing through the object. So if something is transparent, all of the light is passing through. So think about it. If I was looking through a window, I would be able to see everything. If I have something that is translucent, some of the light is passing through. Oftentimes we think of this like stained glass. If I have something that is opaque, no light is passing. All the light is being blocked off. So for example, if I have a door, it's really important to know the definitions of these different words, especially due to the fact that the words are very similar. We have reflection, refraction, transparent, translucent. It's super important that we know the words because it's going to be difficult if we try to find a difference without really remembering it. Yeet, yeet, skirt! Yeet, yeet, skirt, skirt! Look at some examples of light energy that's being demonstrated. Here you can see that we're recording. Hello. Now, it means that the light is bouncing back. So if I have my mirror here and my color, not my color, my light, I have my laser pointing right here and it's bouncing back. You can actually see it really well here. The light isn't going through it, it's going back. In the mirror, you notice that I'm looking at y'all at an angle. This is why I'm directly looking at myself. But if the camera's facing the other direction, that image is going to be reflected in that opposite way. So that's why it looks a little funny whenever you're looking at the mirror at one direction and someone sees your angle at another direction. Here, I have my prism, my refraction prism. You can actually see a little bit, from here. If I turn it at some angles, you can actually kind of see a little bit of that rainbow effect that comes off. If I put it like this and I put my laser to where it's hitting it, I'm going to notice that the light is immediately hitting it and going through it at an angle to where it's going to hit my fingers. I'm literally hitting it right here in the middle, and I see it back here in my arm. Of course you can't because you're viewing it through the camera, but I see it over here. Let's see if I do it like this. Oh yeah, I'm hitting it right at the prism and it's coming off into my bracelets and my arm. A great way to see the electromagnetic spectrum and the light scatter is through a rainbow lens. Here, it helps us see the different colors that are coming off, and if I put it against the light, I get to actually see the colors. It's super duper cool. One of the easiest ways to identify refraction is with a magnifying glass or a Hans lens. This helps bend the light at an angle to where I can see items that are either going to be closer or farther away from me. If I put my magnifying glass up here, you can see the specific details of the wings on the dragonfly. This helps us understand that it's bending the light so we can see items better. However, it's not always the case. Sometimes whenever you have refraction, the light is bending it in an angle to where it will appear smaller. Think about telescopes and binoculars. Think about magnifying glass and even your own glasses. Glasses are one way that helps see your eyesight, whether you need to see farther away or closer. Next, I'm going to have my absorption. This is where transparency comes into big play. Now, if I have absorption, I know that the light isn't going to pass through. It's just going to take it in. So here's my flashlight. I'm putting right through it. Nothing else is coming out. So that's how I know the light is taking in. If you think about it, my fabric, my felt, is opaque because none of the light is passing through. It's completely blocking it out. So this is an opaque item. Something that would be translucent, that has a little bit of light that passes through, is wax paper. If I look at the other side, I can see it bouncing back. No. If I have my wax paper here, I see that the light is going through it, so some of it is escaping. Not all of it's blocked, some of it is passing through. So this is translucent. Next, I have a sandwich Ziploc baggie. Yeah, pretty transparent, completely going through. You don't see any blockage, nothing going through here. So, yeah, totally 100% transparent.